Welcome back to the lecture 6 of this tutorial series, and in today's lecture we're going to be talking about control structure part 2. Right, so in our last lecture we did control structure 1, which was basically the if statements, if else statements, if else if, and else statements, and we also touched the switch statements. Right, now having done that already, I would want us to just dive into lecture 6 for this particular tutorial. Yeah, so I've loaded up a new project on my C program here. I titled lecture 6, and I will just comment here. So basically there's nothing much to discuss in this series. In this particular lecture, I just want to explain to you what loops are basically. So loops, or they call it iteration, is when you want your program to do something, but you want it to do it repeatedly for an amount of time, so long a particular condition is true. All right, compared to what we did in the last episode, which was if statements, or switch statements, which was just a basic decision making statement. That one allows your computer to make a decision and then bring out a result based on that particular, like if the decision was right or wrong. Right, but talking of iterations or loops in general, it means you're telling your computer to do something for like it to keep doing it. You understand? You want your computer to keep doing something until the condition you give it is actually false. All right, let me give an instance now. If I say something like if, let me say 3 less than 4, right, and I said print f. So now if I want to run this code now, me telling my program that if 3 is less than 4, it should print hello world. Obviously 3 is less than 4. What my computer do, since it checks that this statement is actually true, it will run what is in this line 11 and then print hello world to the screen, and it's going to return back to the operating system. Like, it doesn't do more than that. But talking of loops or iterations in C, or in generally like any programming language at all, when you want to iterate something, it means so long this condition inside of this open and close round bracket is true, your program will keep running. Like, it will not stop to keep running and running and running, like so long the condition is true. You understand? So what we do basically, like, you might be thinking, what's now the essence of using loops? Since, like, as you can see now, I said if 3 is less than 4, come today, come tomorrow, come next year, come like 10 years time, 3 is always going to be less than 4, right? So it means your program is actually going to be running forever, which can actually crash your computer, your program, right? So what we do basically while trying to run loops is that we actually start from a number. We call it an iteration, an iterating digits, right, or an iterating variable. Sorry, we call it an iterating variable. So that variable, we're going to like store, probably instead of me writing 3 here, I'll store 3 in a variable. Then each time my program runs what I told it to run, so long the condition is true, I'll keep doing something to the iterative variable, so that at some point in time the condition will be false and then the program is going to break. Reason being that if this were to be a for loop, like I said, this program is going to run over and over again and it will never stop, because 3 would always be less than 4. But if peradventure we could at some point in time change this 3 to 4, then our program is going to stop running, because 4 is equal to 4, and like this statement is already false, it's not more true. You understand? That way your program is going to stop running. But how do we now do this? So that's where the idea of having an iterative variable comes into place. You have a variable starting from a particular number, you get where you want to iterate from, and then you are now going to do something to the variable each time your program runs that loop, you get, so that at some point in time, after probably running like 10, 20, 100 or millions of times, it will definitely stop. So like at a point, you understand? So let me just give you the syntax for writing a for loop. You say for, talking about loops, we have different types of loops. I didn't talk about that. We have for loops, we have while, and then we have do while loop. Now we have actually one more, it's called for each, but in C programming in particular, there's something like for each. You understand? You can write for each loop in C program, but generally in programming there are other programming languages where you can see something like for each. but C program only has for, while, and do while. Right? That's it might be something relating to an OBJ question, I believe. So now, for a for loop statement, this is how it looks like. You have your for, then at the beginning of your, inside of the parentheses, we're taking three, parameters, or like we're having three sections. Let me put it that way. So first section is going to be before this semicolon. Next section is in between, like your two conditions. So your two, sections, and then a last section. Let's just get into it. So first section, after writing your for loop, you want to like declare or like initialize, sorry, your iterating variable. All right. So I'm going to be saying maybe int iterative. I'm using a very long word, which is not meant to be, because like most times it's always I or J. So I'm saying iterative variable equals 0, and after the first parent and the first semicolon, I want to now write my condition, which I'm going to be saying, for iterative variable less than, let me say 5. All right, and then you have the semicolon, and after the semicolon, you will now specify what you want to do to your iterative variable each time this code runs. All right, now let me just put something there and say iterative variable plus plus. This is looking long. Let me change this thing to I. Let me just change it to I. It's too long. But just bear in mind that I is my iterative variable. Right. I wanted to make it obvious. So here we are, guys. As you can see, this is exactly how you write for loops in C. For, then int I equals 0. Int I equals 0 is, like I explained before, we are initializing a variable so that, the condition you want to put in here is going to be a condition based off of that iterating variable. And after your condition, you will now have something that you want to be doing for each time this condition runs. So that's basically it. Let me recap it again. We have int I equals 0. It can be int j equals 0, l, whatever. But like this is my iterating variable. Int I equals 0, stating I want to start my iteration now from 0. Why? Because my condition, I'm telling my program that what I is less than 5. That's the condition I'm giving. So like I told you before, a for loop is going to do it. Check for this condition that you gave it. I is less than 5. Now you initialize I to be what? 0. So your program checks I less than 5, I being what? 0, and then it runs what you told it to run, which is print hello world. Now for the for loop, immediately after doing what you told it to do inside of this your curly braces, like from this place to this place, right? Immediately after doing it, it will come back here to see what you told it to do to the iterating variable, which most times is either you're incrementing the variable or you're decrementing the variable. Now, let me just tell you how this is going to run, like without running it from the computer. First of all, for I equals 0, I less than 5, I plus plus, right? So your computer first I equals 0, okay, it knows that I is going to be 0, right? Then it checks the condition. Your condition you give it was what? I should be less than 5 is the condition, right? Then it comes and reasons the logic. I was 0 and 0 is less than 5, which is true, right? Then it prints hello world. Then it goes back here and it sees that you have what? I plus plus. Now I plus plus means that what? It should like increment the previous value of I by 1. So now it will now recheck this condition again after doing what it just did, which was incrementing. Now incrementing from 0, like incrementing 0 basically is like you're turning 0 to 1 because you're adding, each time you increment, you're adding something. And I plus plus simply means add 1, right? So now I is already what? 0 plus 1, which is 1. Is 1 less than 5? Yes, 1 is less than 5. All your computer do to run what you told it to run again, meaning print every word on the screen, and then do what again? Do what you told it to do to the iterating variable, which is what? I plus plus. So now your I is no more 1, it's now going to be 2. Now it's going to come back again and check 2 is less than 5, then print this out, and then increment I becomes 3, then to do it again, I will become 4, and let's now say finally now, after doing 4, increment I again by 1, I becomes 5. Now at that particular point in time, 5 now, less than 5 is a false statement. It's not true. 5 is not less than 5, right? So that is the only time your program is now going to jump out of this loop, like it will stop that thing that it's doing about checking if it's true and then running what you say it should run. It will stop that and now proceed to anything after the close of the calling process, meaning it's done with the loop already. You understand? So that's what I'm saying. For loops, not just for loop, all of the loops, you have an iterative variable that you want to like base your condition off of, so that you can be doing something to your iterative variable, either incrementing or decrementing it. So at some point in time, the numbers will catch up and your program is going to stop running that loop. Just like this one, we started our I from 0, and at some point in time I got to 2, 3, 4, and it finally got to 5, and from 5 was no less than 5, so the program is going to terminate, to stop and jump out of this loop. So now let's just run this now and see what we have. Let me print I itself in place of hello world. So I want to print I, and I want to put new lines. So that's what I want to do. Build and run. So as you can see, we have hello world printed, which was from this line 8, which is fine because that was what we wanted. And then you can see now printed 0, 1, 2, 3, 4, and after 4 the program stopped. You understand? That's what I'm saying. So for or while or do while, generally loops are you want to perform something for a number of time, so long a condition is true. But at the same time, each time your program runs that condition, like each time your program runs what you told it to run, so long the condition is true, it's going to be doing something. You understand? So initializing I at 0, then you're telling your program that you have this condition, 0 is less than 5. Okay, yes, it was actually true. You run what is here, and then it does what you told it to do, which was increment. I turns to 1, this condition is true. It runs this, I turns to 2, this condition is true. It runs this, I turns to 3, like that until the condition is false. You understand? Now let's do another example. Let me say let's just build a multiplication timetable, like a multiplication table, sorry. So let me say, let's make our program fun. We've been doing boring things all along. Let me say enter. Okay, so guys, I've written a code that just basically displays, enter the number you want to display its multiplication table. So I want to build a program now with loops that is going to when somebody enters, and then I use scanf here to like collect an input from the user, which is just a number. So if somebody inputs 10, 20, 11, 5, 7, whatever, want to take that number now and display the timetable, like the multiplication table of that number. So if they input like 5, I want to show them 5 times 1 equals 5, 5 times 2 equals 10, down to maybe 20. All right. So now how do we achieve that? It's a multiplication table, right? 5 times 1, 5 times 2, 5 times 3, meaning my program is going to keep running, starting from where? 1, 5 times 1, down to, I want it to stop at 20, right? So basically, with the knowledge I'm teaching, just like start your I from 1. So you want to, make your program start iterating from 1, you understand? And where do you want to stop? I want to stop at 20. So we can use 20 here, but we'll make sure that our condition is less than or equal to. Now this is because, like, just like we used to imagine, once this gets to less than 19, it does I plus plus, I turns to 20. Now if you leave this thing as less than 20, is not less than 20, so your multiplication table would have stopped at 19. But this is equal to, once it gets to 20, this condition will still be true because 20 is equal to 20 and it will run it. But when it's like iterated by 1 and I turns to 21, then this condition will be false. So that's just like a little explanation to why I'm going to be adding equals to this place. So now we have I starting from 1, and then I want to stop it at 20. So what I basically want to do first is, like the way I printed my I to the screen before. So if I will leave this code like this, it is going to be printing 1, 2, 3, 4 down to 20, right? So what I want to do is, let's just make it more fun. Instead of that, let me just have, percent %d was I, then let me put a percent %d here to be the number the person imputed, then space multiplied by then that, and then equals percent %d num asterisk I. Now, if you understand this code without me explaining, then you're actually like a genius, right? Now, the point is, what I'm basically doing here is I want to like print something like, let me just show you what I want to do, like 5 times 1 equals 5. This is exactly what I want to do. Now, to achieve this, I need to print to my screen, definitely. Now, what am I printing? I first need to print 5 to the screen, but I'm assuming 5 is the number the person inputted here. So if person can input 10, you can input 20, you can input 1000 safe. So what I want to do is, I want to, print whatever is here, whatever the person inputted, which is going to be an integer. So I'm using %d, and like the placeholder here is for num. Then asterisk here is what is here. Then my 1 here, instead of it to show 1 every time, right? Because I'm iterating it, and I know it's definitely going to start from 1 and it's going to end in 20. So I want it to be like 5 times 1. Then when the loop runs again, 5 times 2. When it runs 5 times 3, down to 20. So in place of 1, I use another %d here, whose value is going to be I, and then I put my equal to, which is this, and then 5, which is basically just multiplication of this and this actually, and that is what I use here, %d, and I'm doing calculation in num asterisk I. So if you run this program now, we should have a multiplication table of whatever number we input to the screen. Let's see. So as you can see, it first of all asks me enter the number you want to display its multiplication table, like I wrote already. So let me do 7 and then enter. As you can see, just like what we wanted, 7 asterisk 1 equals 7 times 2, 14, 21, down to 20. And this is the sweet thing about loops. You understand? If you want to write this kind of a program now with your hand, you need to like be writing 7 multiplied by 1 by 2 by 3, until probably 20. Now imagine you want to like make this timetable now goes to something like, maybe I want to show down to 100, like 5 times 1, 5 times 2, down to 5 times 100. All I just need to do is to change my condition. Tell my program that is going to run this program from 1, you understand, down to 100. And if you run this thing, it's going to perform exactly the way you want it to. Now you can see again, it said enter the number you want to display its multiplication table. Now, whether it's a big number or a small number, it doesn't really matter. So I'm just going to use, let me use 20, right? And press enter. Now, as you can see, it's running, and it has run finish in about, I don't know, less than seconds. Sorry, less than from seconds. Now, like you can see, we have 20 asterisk 1 equals 20, 40, 60, 80, 100, down to 20 multiplied by 100, which is 2000. You understand? So that's the beautiful thing about loops. I just told my program, I want you to do something. How many times? 100 times. All right. And I want it to be that what? You start my program from 1, and then each time you run the program, keep incrementing I. You understand? So my I go from 1 to 2 to 3 to 4 to 5, down to the last digit it can, where this condition is no longer true. And that is it. Now, that is all for loops. That's all for loops. You can actually play around with these things because I can't do a lot of examples because of the time of this tutorial. Now let's go to while loop. Now it's the exact same concept that is applied to like all of these 3 things, you understand? But it's just choice of or preference, you understand? Or the mode of, or the kind, like what you want to use to achieve is what will determine which of them you want to use, you understand? Now for while loop, you say while, and then open up and close your round bracket as usual, and then this. But now what makes while different from for loop is such that in for loop, your iterative variable is going to be declared and you'll be like giving it its value right from your parentheses, and you also be stating your condition inside of the parentheses, and still even be performing your iterative operation, you understand, inside of your parentheses still. But for while loop, the only thing that goes into this parenthesis is your condition. So you want to say I less than or equal to 100. Now, because of I don't have anything that is I need to first declare I before my while loop, you understand? So I'll be like I equals 1, and then I'm telling my program now that while I is less than 100, you understand? Let's just do the exact same thing. Let's do this multiplication table again. Print this. Now you might be wondering, like I told you, if you don't do something that will make your iterative variable iterate to a point where this condition is false, your program is going to run forever and it will cause your computer to crash because it can't keep running. You're using your like computer memory. You understand? So it will definitely get to a point where your computer will crash. So to avoid that, after you write all of your code that you want your program to do in this while loop, you need to, at the end of your statement, perform your own iteration yourself. So in place of I plus plus here, which was in the for loop parenthesis, you are going to put it just at the bottom, just below, sorry, just before the close of this curly braces for a while loop. Now, as you can see, it's very, very similar. For for loop, all of the things you want to do is just inside of the parenthesis. But for while loop, you declare your iterating variable first, then you put the condition inside of the while loop, and then just before your program closes or terminates, you want to perform your iteration here, and it's the exact same result you get. Now let's run this. Now again, it says enter the number you want to display in the multiplication table. Let's do 9 this time around, and as you can see, the exact same thing. 9 down to 9 times 900, right? From 9 times 1 to 9 times 900. Now it's the exact same thing we follow. We declared our iterating variable first. We gave our condition inside of our parentheses for the while loop, and then we iterated just before the close of our curly braces, so that our program, after running, it's starting from 1, right? So it checks 1 is less than 100. That is true. It does what? This, and then it does this. Now I becomes 2. It runs this program again. 2 is less than 100. It prints this. It iterates I becomes 3 down to it does it for 100. Then it does it for 101. But in place of 101, this condition is false, and then your program terminates out of that loop. You understand? Very, very simple. Now let's go to do while loop. Now for do while loop, it's quite different from both of these loop because, for instance, we are starting our I now from 1, and we are saying I is less than 100. Like I less than or equal to 100 is the condition I want to check for, right? Now if I change this thing to I greater than or equal to 100, meaning like I want to check if I is going to be greater than or equal to 100 for this loop to run. Now, obviously, 1 is not greater than 100 and it's not equal to 100. So, for like your while loop and your for loop, this program is automatically not going to even print anything at all. It will never print any of the multiplication table because this condition is not even true. So, what would it do? It would just like, jump the loop since the condition is not true. You understand? Same thing for for loop. If you put a condition that is not true inside of this place for the first iteration, then it's definitely not going to run because the condition is not met. But for your do while loop is going to run the first iteration, whether whether your condition you give is true or false. That's the difference between two of them compared to do while loop. Do while loop is going to run the first iteration before it even considers your condition. You understand? It will like definitely run the first iteration before it checks your condition. Because even writing the code, you understand that it first says do, then what you want to do goes here before it now checks y. So as you can see, it's a very funny like statement because it is do while. You understand? So I first want to do something before I even check any condition at all. You understand? So yeah, let me try to say, let me just do print f and let me say hello, right? But now I want to do my while statement to be such that I is greater than 100. You understand? Let's do I greater than 100. Let me just comment this out. So like I said before, when you want to run a while loop and the condition is false, it will never run because my I is 1 and I'm trying to tell my program to like check if 1 is greater than or equal to 100, which is false. So if this was to be run with this while loop, it's no work. When I'm trying it with do while loop, and I want to show you that regardless of the fact that this condition is not true, this program is going to print hello before it even checks this condition. Then it will now stop. But that first iteration, it will always run it first. Like it will always do what is here first before it even checks this condition. Now let's run this. Now again, enter the number you want to display this multiplication table, and I don't even need this one this time around. Let me just put any number. Like you can see, it printed hello. which was from this particular line, from line 27. But the fact that, you know, I was not greater than 100 did not matter to it. Now let's just do like we wanted to print our usual thing. Let's try to print the usual thing here, right? So now what I'm trying to tell you is that the fact that this is a dual loop, this thing is going to first print 5 times 1, sorry, whatever number you put, times 1 equal to, the number, before it now checks whether or not this is even true. Now let's check. Now for this, let me just use 6. As you can see, like I said, it printed 6 times 1 equals 6, even though this condition is false. Now let's just change this condition back to be true, so you now see what exactly is going on. Now before we run, sorry, I forgot to add my iteration here. So I need to do I++. Please do not forget to do this. You can actually try it. Try to run the program without putting I++. But be ready to quit the running program because it might crash your computer. So now let's use same 6. And as you can see, just like every other code we've been running, it's still the same result. 6 times 1, 6 times 2, down to 6 times 100. Now, I hope you clearly understand the difference now. For your dual loop, whether or not this condition is true, it will first of all do this before you now even check your while condition. Now, if your while condition is false, it will stop, but it has already done this first one. But if your while condition is true, then it will come back and continue doing this for as long as this thing is true. So that is basically all you need to know about your for, dual, and your while loop. Now I could end this video right now, but I want us to even touch one more thing, which is nested loops, right? Nested loops, and it's quite interesting. And let's talk about nested loops. You can do this for any of them actually, while, for, dual. But for the sake of this video might get too long for that, I'll just leave for my for loop. Now what I want to do is let me reduce this now from 100 to 10. So now this should be printing 2 times 1 to 2 times 2, 2 times 1 to 2 times 2 for 1. Like, what I want to do is a nested loop. Now what is nested loop? Nested loop is like you have a loop, but you want to put another loop inside your main loop. And you can even put another loop inside that loop inside the main loop. You understand? So it's just like how you structure it. So I can have a for loop, then another for loop, and then another for loop. So how it's going to work is such that this for loop is going to run for the first iteration, but that first iteration is going to also the first iteration means is, let me just demonstrate it here. So let's say you have a for loop here, and inside here you have another for loop. So what basically happens is this, the main for loop. Let me use this one as A, B, and C, like A, B, C. You understand? So for loop A, which is the main loop, it's going to first run. You understand? For I equals 1. Now the fact that it's running for I equals 1 means it's going to do everything inside here. You understand? Down to the last part of the code before it iterates and redo. You understand? But the point now is inside of what you told it to do, you now nested another for loop. So definitely it has to pause its own operation because it's still in its iteration 1, and then do what is in this for loop. Now this for loop also will now start its own iteration 1. So let's say here is int j. Now you can use the same variables. You can't put I here this time around because you run into an error. So let's say here is int j equals 1, and then some conditions, and then j plus plus. Right, now this one is going to start its own loop. You understand? From what j equals 1, and it's going to what do what is also inside of it. It's normal for them as for loops to run what is inside of their parentheses, this curly braces, sorry. You understand? So now it checks j equals 1 and it checks the condition. If the condition is true, what would it do? It will now want to run what is inside itself, and now what is inside here is also another loop. So this will be on iteration 1, your loop B will be on iteration 1, your main loop, which is loop A, will still also be on iteration 1, and then your for loop would now run its own. Let's say it's one less than, let's say I less than maybe 5. You understand? So it will run its own 1, 2, 3, 4, 5. Then after running that, you now go back to this loop for loop B. Do you understand? Now for loop B will run for the second time. But mind you, each running second time means it also has to run this for loop now, again, because you are basically telling me that whenever you iterate j plus plus, it should do what is, inside of itself, what's inside of this curly braces, which is a for loop. You understand? So each time it iterates j from j equals 1, let's say this for loop was to print 1 to 5. 1 to 5 will be printed to your screen. When it does j plus plus, when j equals 2, 1 to 5 again will be printed to your screen. Once it does j plus plus and j is 3, it will be printed to your screen. Now, once this one is done again, then it will now go back to your main loop. Now, I, which was 1, will now turn to 2. Now, mind you, it turning to 2 means it will check for this condition. Then 2 is less than 10. Then it will now, start running all of this thing again. So all what happened before of 1 to 5 printing, then j, doing its thing, will now happen again. You understand? Now, it might seem like, something that might be stupid or something that might not be needful to you, like as a beginner, but I kid you not, this thing is like a real life. It's something like we handle in real life. Like, I'm not joking. You can have this kind of like, let me say, solution. Don't let me call it a problem in real life. You understand? Where you have a data, you understand? You want to like check through that data. Then inside that data, there's another data, and then you want to check for each of those data, and then like it is actually a real life like solution. So let's just do the one for 2. I think 3 will be too complicated for a beginner's understanding. So let's say from here now, let me just basically just do a basic thing. So I'm not like make it so difficult for you to comprehend. Let me just basically print I to the screen here. So each time this loop is running, I first want to print, let me just term it loop 1 variable I equals. So I want to print loop 1 variable I equals, you understand, for that one. Then inside of this for loop for j, let's just do j less than, let's say 5, less than plus 5, you understand. And then let me just print the value of j and then space it. So what I want to achieve here is something that it first print loop var equals then 1, which is the first iteration for loop 1, and then underneath it, let me put a new line after my passing d here. I hope you're following me. Then underneath it, like having this new line, I also want to put a tab /t. Now, I don't know if you understand /t, but /t is like adding, I think it's horizontal tab, then /v is vertical tab. That's escape sequence. You understand? They are in the PDF I sent, so you can go check it out. So now what I want to achieve is first print loop 1 var I equals 1. Then underneath it will like give 2 tabs, so like spaces, and then print all of the values of j, which is just this iteration basically. I just want to print j, and then I will run again, like all of this thing will run again. We have loop 1 I equals 2, then all of the value of j 3, etc. So let's just see how this goes. Let me change this into just I equals that, and we're set for our first iterative statement. Sorry, nested iterative statement. So as you should have thought, with the program we currently wrote, I'm not going to be using this number we're collecting. So let me just put any number. And as you can see, we have loop I equals 1. Oh, it's quite scattered because I did not format it well. Loop I did not format this thing well. I'll rewrite this code now and we'll see it together. As you can see, it's loop I equals 1, then loop I equals 2, equals 3, equals 4, equals 5, equals 6. Like loop I equals 10. Like we ran up to that instance. And as you can see, for each of those loop I equals whatever, we are having a fresh, loop 2. You understand? That's the second loop of j. 1, 2, 3, 4, 5. As you can see, then we have this loop I equals 1, 2, 3, 4, 5. Let me revise what I wrote actually. Now, what I wanted to do was not supposed to be like this. It's meant to be here, and I'll explain why actually. Print f \t. So now, me adding \t here, which was that, as you can see, those numbers were spaced between each other. Me adding the space here shows that for each time j will be printed to the screen, it's always going to be adding that space. You understand? Like when J printed 1, he first added space, then 1. J ran for the value of 2. He did that space 2, then 3, then 4, then 5. But what I just wanted was, before it even do J, I want to first have that space and then print all of the value of J. You see what I'm trying to say. Then what I want to do is, after this loop again, I also want to print a new line. This is exactly what I wanted to do. You understand? Now if you pause this video and like read this code, you would understand what I'm trying to say. So I first want to print 2 tabs. Then in my for loop, I will now print all of the values of J. So from J equals 1, it will print 1, then just 1 space, then print 2, then 1 space, then 3, then 1 space, then 4, then 1 space, then till it get to 5. And after running this loop, since it's already at 5 and it does J plus plus, J turns to 6. 6 is not equal to 5, or is not less than 5. Then it will come to this line and then print a new line. Then our loop 1 will start again when I is going to be 2. Then by then this will run again. I don't know if you're following me, but let's just see how it goes. Let me make this double new line, so we know. Yeah, this is fun. So this doesn't matter again, like I said. And as you can see, that is everything I wanted. Like, this is everything I wanted. So loop 1 printed, I was 1 here. Then because inside of I we had another for loop, the for loop was to print 1, 2, 3, 4, 5. And then I told it to print a new line after that. And then the first loop, let me just see if I can check to or something. Okay, yes, this is it. So this was loop 1, I equals 1 from line 17, as you can see on the screen, right? I equals 1, and then inside of it we now add this for loop for J. So we're just basically printing values of J, which was 1, 2, 3, 4, 5. And after that, if you check line 23, we had to print a new line. You understand? So actually 2. Then on the second line, we now started printing, the iteration started from line 16 again, when I became 2. You understand? It did I plus plus, so I became 2. And then we have loop I equals 2, and we printed this tab here. So we did this new line, we jumped to this line, we added 2 tabs, 1 tab and the other tab, and then we printed values for J again, which was 1, 2, 3, 4, 5, and then it kept running like that down to the end, which was exactly what I wanted. So as you can see now, loops are basically like, they are great tools. Actually, it saves you time trying to do something. You can actually just iterate and let your computer run it by itself. Another thing I really want to talk about before we end is just that, rather than like compared to just doing I plus plus, you can actually iterate more than once. You understand? So all of what we've been doing this morning is I plus plus, which means I plus, like, I is equals to I plus 1. You understand? That's basically what I plus plus is. And I want you to know that you can actually do iteration for not just I plus plus. Not just, you can increment it more than 1. You understand? So I can do I plus equals 5 here. You understand? So this basically starts from my I is going to be starting from 1. Then after I run all of this code, trying to come here to iterate, instead of iterating by 1 when I will turn to 2, it will now iterate by 5. So it will be 1 plus 5, and my I is going to turn to 6. So that way this code will now run for 6 less than 10 is true. Then it comes here again, 6 plus equals 5 means 6 plus 5, that's 11, and then the loop will no longer run. So if you have to run this program now, we just have like 2 print out to the screen when I is going to be 1 and when I will be 5, because after 5 the next value for I is going to be 6. Sorry, after 6, when I is 1 and 6, because after 6 the next value for I is going to be 11, and at 11 this condition is false, so the program will not run. So let's just run this and let's conclude the class. Again, this doesn't matter. Let me just 0. And as you can see, like I said, it's only ran twice. I was 1, it ran this, then it iterated by what? 5. So I became 6 because I plus 5 is 6. Then you ran the loop for 6 because the condition was still true. 6 is less than 10. Now iterating it by 5 again, I becomes 11. You understand? And 11 is not less than 10, neither is it equal to 10. So the program terminated from the loop. Now all of what I just explained can be done the exact way in while loop and do while loop. You understand? But instead of having your int I equals 1 year and int j equals 1 year, for a while loop, if you want to have your nested while, it will just be while, but like just the exact same format like this. You understand? Declare your j, int j equals 1, and then while j equals something, then what should happen should happen. You understand? Same thing for your do while loop. Just do it the exact same way, and that is all. So that's the end of this tutorial, guys, of this particular lecture. We are just down to, I think, 2 more lectures, which is just arrays and functions. Yeah, and those 2 lectures are just, they can be merged, but I don't know. It depends on how the tutorial is going to be when I would be teaching it. So that brings us to the end of this lecture, guys. If you found my videos useful up until this moment and you really like them, and do also subscribe to the channel and give the videos a thumbs up so other people too can find it useful, just like we did, and other people too can learn from it. So bye, guys, and I'll see you in another video.